Alright guys, so we're going to go ahead and start lesson 6.1, which has to do with linear functions. As you can see from the top of your page, which is on page 155 of your textbook, it says, how can you use graphs and equations to identify linear functions? So this first part that has to do with the explore activity is very simple. It's based off of the last lesson that we did, or the last module from module 5. So if you read this first word problem, it says you get a job planning birthday parties. You're paid a flat fee of $80, then $15 for each hour you work. The function defined by f of x equals 15x plus 80 represents your earnings in dollars when you work x hours. So assume you get paid for fractions of hours. Basically what that means is that you can work an hour, you can work an hour and a half, you can work 2 hours and 15 minutes. That's what they mean by assume that you can get paid for fractions of hours. Now, what that means is, as you can see here, I've already gone ahead and filled all this in for you because this is based off of the previous module that we've already done, so you should be able to work this out on your own. But what that means in that last sentence that it says, assume you can get paid for fractions of hours, is that this is going to be a continuous line starting at 0 hours because you cannot work less than 0 hours. So there's no such thing as negative hours worked. Now, the way that you get these values here for f of x is by simply using that function that they give you and solving for f of x by using those x values that have been provided for you and substitute it into the x of the function. So right here we have x is 0, so we can go ahead and do f of 0 equals 15 times 0 plus 80. And so we can go ahead and start doing our calculation. So 15 times 0 is 0, and 0 plus 80 gives us 80. And so that is how we go ahead and we get this first value. Now, in order for us to get the value for when x is 1, we would simply do the exact same thing, but substituting 1 instead. So we have 15 times 1 plus 80. And so 15 times 1 gives us 15, and 15 plus 80 gives us 95. And that's how we got that second value. Alright, to get our third value of 2, again, we would do the exact same thing. So 15 times 2 plus 80. And 15 times 2 is 30, and 30 plus 80 gives us 110. So you would simply continue following that exact same function rule and do it for value 3 and 4, and that is how you would get 125 when x is 3 and 140 when x is 4. Now, for example C, it's asking us how we know that this is a function. And just as we mentioned in module 5, we said that functions are only when your x values are not repeated. And so in this case, since this is forming a straight line going upward, we can see that each x value is paired with only one y value. So that is the answer for letter C, for how we know that this is a function. So now to move on into our reflect questions, you guys see here, for number 1, it says to identify the reasonable domain and range for the function f of x equals 15x plus 80. Now, a common mistake which a lot of students made is that they would put all real numbers. But in this case, notice that it's specifically asking us a reasonable domain. Now, in this particular example, we're talking about working a particular number of hours. So since we cannot work less than 0 hours, but we can work more than 0 hours and any number in between, because it does tell us that we can work fractional hours, we can go ahead and say that a reasonable domain for this function is a set of all real numbers so long as x is greater than or equal to 0. So your domain would be x greater than or equal to 0. And for our range, it's basically the exact same thing. Remember that your range is your set of y values. Now notice that our y values are starting at 80. And if you went back into the word problem, it specifies that we get a flat fee of $80 when we're working. So because we're getting that flat fee of $80, no matter how many hours you work, you're always getting those $80. And so for that reason, our range is going to be f of x values, because again, we're dealing with our y values. So it's f of x values that are greater than or equal to 80. Now, when we go into question number 2, it says to describe the pattern that's formed by the points in the graph that are from the table. So if we look at this graph, what does it look like? It's one line that's going up and to the right. So notice the direction of that arrow. It's going upwards and to the right. Okay, so for every time that it goes to the right one, it's actually increasing by 15, because that's the value that's changing. It's those $15 per hour that's making that change. So what we're going to write here for our pattern is that it's moving horizontally to the right 1 unit and up 15 units from the previous point. So moves horizontally to the right 1 unit and up 15. Okay, so that's what you would be writing in for this explore activity. Now, if you flip your page and go on to page 156, now we get into the actual lesson. That first part was just our explore activity. It's using the previous knowledge that we've learned from the module 5 and applying it to another type of a question. So here we're talking about identifying linear functions. Now, a linear function, as you see, is highlighted there. That's a key word. That's a new vocabulary word for you. A linear function is a function whose graph forms a line that is not vertical. It's very important that you understand that it cannot be vertical. The graph at the right is the graph of a linear function. So they're giving you here an example of what a linear function looks like, very similar to the graph that we just plotted our own on the previous page. It says both the domain and range of the function are the set of all real numbers. Notice that you have arrows showing continuation on both ends of that line. Because it's showing continuation on both ends of the line, that is why this is all real numbers. Now it says underneath that, it says if a function is linear, then it can be represented by a linear equation. And a linear equation is any equation that can be written in the standard form below. Now this is something that's very new to you guys. Up until now, you guys have been learning equations very similar to y equals mx plus b. And for the most part, whenever you guys graphed a line, especially last year in 8th grade, you had it in y equals mx plus b. And we know that that is slope-intercept form. And so now, today, what we're learning is standard form. As you can see here, they have ax plus by equals c, where a, b, and c are real numbers, and a and b are not both 0. So you cannot have both a and b equal to 0. The other thing is down here. So it says, notice that when a linear equation is written in standard form, the following are true. X and y both have exponents of 1. So notice that there's no exponents here for x and there are no exponents for y. You cannot have a linear equation have any exponents in either one of those x or y values. You also cannot have x and y being multiplied to each other. And the last thing is, x and y do not appear in denominators, exponents, or radicands, meaning you cannot have the square root of those numbers, you cannot have fractions, or exponents. So over here in this example, you guys can see it says, tell whether each equation is linear, and if so, graph the function represented by the equation. So in that very first example, you have negative 12x plus y equals negative 4. So it says the equation is linear because it is in the standard form of a linear equation, where a equals negative 12, b equals 1, and c equals negative 4. In order for us to graph that function, we first want to go ahead and solve for y. And this is where literal equations plays a big deal in this, because you'll need to know how to rearrange the original equation into slope-intercept form so you guys can go ahead and solve it easier and get points that you can plot on a graph. So in order for us to rearrange this and solve for y, we can go ahead and add 12x to both sides. so that it goes ahead and it cancels out from here. And so now we have y equals -4 plus 12x. So now it makes it very easy for us to go ahead and substitute points on an x and y table that we can later use to plot the points. So in this case, your textbook used -2, 0, 2, and 4. So if they go ahead and you substitute -2 into x and then add over here, you'll get -28. Same as if you substitute 0 into x, this cancels out and you have -4 plus 0. If you substitute +2, you'll have -4 plus +24. And so that gives you 20, and so on. And when you go ahead and use those points to graph, you can see here what it looks like. Now, for part B, it says y equals 12x squared minus 4. Now, that is not a linear equation because this exponent x is not 1. So it's not going to be linear because you see right here that you have an exponent with the x. And similarly with the next example, you have x times y. And as it said before, you cannot have that. And so because of that, this is nonlinear. Now moving on to your reflect question on page 157, we see here it says to use the bulleted list above example 1 to write at least 2 more equations that are not linear. So this is you coming up with your very own equation of something that is not linear. So you can use something like y equals 5 over x plus 14, because one of the things that it said was that you cannot have any fractions with your x. The other thing is that your x or y values cannot be used as exponents. So you can have something like 12 to the x power plus y equals 7. So neither one of those would be linear equations. Now your last one is to make a conjecture. It says here, what do you think the graph of a linear function has to be not a non-vertical line? So why do you think that it cannot be vertical? So think about that for a second. Now remember that we said for it to be a function, you cannot have any x values being repeated. So if that's true, a vertical line, which would be going straight up and down, would have x values being repeated. And so because of that, you will have repeated x values, making it to be not a function. So that goes ahead and completes our lesson 6.1 for right now. I will go ahead and do the horizontal and vertical lines in a different video.